As programmers, we have a bit of a habit of sometimes doing things which computers don't like, such as trying to divide things by 0. So let's take 1 divided by 0. Now, Python obviously doesn't appreciate this gesture, doesn't like it one little bit. And there are actually a whole load of different things which we can do which will generate errors like this. And basically today, we're going to look at exactly how this works and what Python does when we create errors. So when we do silly things, what does Python do? Well, when it's fed up of our rubbish, the first thing it'll do is it'll pause our program and stop it from running. The next thing Python will do is create an object containing data about our idiocy. And these two steps up here together are what's known as raising an exception. So when we talk about raising an exception, we're talking about the process of pausing the program and then Python creating an object, basically letting us know what's happened. An object which contains data about what's gone wrong and what the problem might be. Now, after it's done that, Python checks to see if we've handled the issues. Now, what does handling our issues mean? It doesn't mean the same thing as handling your business in prison might mean, or anything like that. But it means that Python's going to go and take a little look to see, right, have they tried to rectify their problem? If we haven't, then it'll put an end to our misery and end our program. But if we have, it'll allow our program to carry on running. So that's absolutely wonderful. So why don't we take a look and see if we can see a little example of this? And we're actually going to do a few more things as well. We're going to have a look at exactly how to handle errors. Then we're going to take a look at what errors are made of, what they're constituted of, and what goes into an error. We're going to look at what happens if you have errors whilst handling errors, so meta errors. And then we're going to take a look at what and how you can explicitly chain errors and how to make this whole process a little bit more useful. So first of all, let's take a look at handling errors. So we're going to generate an error for ourselves. And what we're going to do is we're going to go looking for something which doesn't exist. So why don't we import something which is not really there? Great English, off we go. And here we can see that we've generated an error. Python doesn't like what we've done. And just to prove here that the program hasn't come to an end, let's have this print statement here which says fin. So technically speaking, if we manage to get all the way through our program, then we're going to see that at the end, just the word fin, finish. There we go. So our program executed, got all the way through that time. So now let's put this import line back in. We've tried to import something that's not there, and Python doesn't like that. So it's giving us some information. It's paused our program. It's created an object, which is where we're getting this information from. It's checked to see if we've handled our issues, which we haven't, and it's put us out of our misery, and it's terminated our program. So what we need to do then is handle our issues. And how do we do this? Well, we use something called a try and except block. So try, now in Python, we designate blocks with colons. So try, and then we also need to use a tab to show where our block starts and ends. So we're going to try and do this. And if we're not able to do that, except, you can see try and except are both keywords, so they change color, except, let's just print for now. Let's just print no. So we're going to try to do that. If it doesn't work, then we're just going to print no. And we can see here that we've executed that and our program has completed. It's got to the end. We've handled this. So it's paused our program. It's created an object and it's checked to see if we've handled our issues, which we have. And if so, happy days. Now, I said here, though, that we've created an object containing data about our idiocy. But where is this object? How come we can't see this object? Well, we can't see it because we haven't asked to see it. So why don't we ask to see it? But first of all, let me introduce another problem. Let's try doing this. Let's try having another problem here. 0 divided by 0. We're just going to do that and see if there's an issue there. Now, of course, that creates an issue, but we've handled that issue and we've handled this issue. So which issue here is being handled first? And the reason I'm saying this is because as a programmer, you might handle one problem. But the problem is, if there's another problem in your code, which is also hurting things later on down the line. So, for example, if we say Bob equals 0 divided by 0, and then you try to do something like print Bob, then you might run into problems. And then, oh, name error, Bob's not defined, but it is defined here. What's the problem? And the problem, of course, is that you're trying to assign something that's 0 divided by 0. You're dividing by 0. This could be a 5 or a 10 or whatever. But if we're dividing by 0, that's a problem. But we don't know exactly which of these problems has caused this error. We've handled an error, but we don't know which one. So what we need to do is be specific about which errors we're handling. So instead of just saying except, let's say except module not found error and run this again. Oh, there we go. And now we can see that what's actually holding us up is a 0 division error. So now we're getting a bit closer to gaining access to some of this useful data that Python automatically creates about the errors which we handle. So now what we're going to do is we're going to go except 0 division error. How do I know what to type? Well, it says it down here. I'm not even having to do any work, you see. Copy, paste, it's exactly the same word. So except 0 division error, print, and why don't we print something different for this? Why don't we print nope, nope. There we go. So obviously the 0 division error is, the 0 division error is the first thing that we've encountered. So that's the issue. So we're getting nope, nope, and so it's not running. We've still got this issue right here where we're trying to print Bob, and that's a name error. So why don't we handle that now? Why don't we say try to print Bob? And you can probably guess where I'm going with this at this point. And we're going to accept, we're not going to accept just nothing. We're going to accept name error because it's told us what error we've created. One of the advantages of having an interpreter as opposed to a compiler, you can just do this. And there we go. And what we're going to do is we're going to print nope, nope, nope. Now all of this nope stuff is getting rather tedious because it's not actually giving us any useful information about our errors. But I'm going to go back to this comment again though. Create an object containing data about your idiocy. Well, where is this data? Well, how about we gain access to it? So accept module not found error as E. So we're giving it a namespace now, E, and we can actually print that. So let's see what that looks like. It looks like nothing. Okay, that's because module not found error is not the first error that's being found in this try block, is it? It's the 0 error. So tell you what, why don't we accept that as E as well? And just by the way, it doesn't matter that these are both called the same thing. We could call them different things if we wanted to. Let's call this one Bob. And let's call this one Jane. The letter you assign it to really isn't important. The important thing is that you just use the same namespace here as you're assigning the error. So save and run. And we can see here that now we've got our 0 division error causing an error. We're trying to do this. It's failing. We're handling it here. And now it's printing Jane, our 0 division error, and it's actually telling us that we've got a 0 division error. So why don't we do this here as well? Why don't we try to print Bob, accept name error as E, and then why don't we try printing E? And now we can see that we're actually getting some useful error messages. We can tell that there's been a division by 0 error somewhere in our code, which is bad news. We've handled that. Then we've handled another error where Bob is not defined, but our program is still completed, which is fantastic. We're aware of all of our errors. And so basically, that's how to handle errors in Python. Now, the next question is, what are errors made of? How do we know what exactly our errors are made of? Why don't I just move this up here, because that's the next thing that we're dealing with. How can we find that out? Well, I said here, remember, we're creating an object containing data about our idiocy. And if I go down here and I type help, so that'll basically enable me to interrogate any object. So help 1, and 344 lines of text, blimey, let's open that up. And it's telling me that 1 is classed integer, and it's giving me lots and lots of details about this number 1. It's telling me that it has an add method, it has an and method, it has a bool method, so we can change it to a bool. It's telling me all these different things that I can do to my number 1. Do you think there's a slim chance that we might be able to do that for an exception as well? Well, why don't we try it? Just to make this a little bit easier, we're going to focus here on the module not found error. So I'm going to get rid of this Bob divided by, I'm going to get rid of this 0 error here. And what I'm going to do now is change this to E as well. So accept module not found error as E. And what I'm going to do is I'm going to go help E and see if I can find some more information out about my error. Look at that, I've got 101 lines about my error. Let's scroll down. So what can I find out about module not found error? Well, the method resolution order is module not found error, import error exception, base exception object. What does this mean? Well, basically this means that this is a child of this, which is a child of this, which is a child of this. So this inherits all of the attributes of this, which inherits the attributes of this, which inherits the attributes of this. we'll come back to that in just a second. But let's see if we can find out any more useful information. Ah, look at this. Message, name, and path. Let's see if we can access some of that information. Rather than just printing E here, let's print e.msg. Oops, msg. And then we'll also try printing. I'm just going to copy and paste this a couple of times. Then we'll also try printing e.name and e.path as well to see what information that contains. So now we're gaining access to some of this information in our error. So this is a module named, no module named something which is not really there. So that's the message. Name is the name of the thing which we've tried to get. And then path is none. And that's probably because we're trying to look for this that's because there is no path at the moment. So we can see here that we're able to get more information about our error, which is absolutely fantastic. And we're gaining access to that via this thing here, E, okay, via this little didgeridoo here. Now, we also know that all objects reside somewhere in memory. So why don't we just go, look, we've also got access to this traceback thing here. So why don't we have a look at this? Traceback. And why don't we see if we can find out anything interesting from that? Nothing really interesting, but we can see here that it occupies an address in memory. So that's the object that gets created at stage 2. So Python's paused our program. It's created this object, module not found error, which we're saving as E. It's checking to see if we've handled our issues, which try, except we are handling it. And we're handling it in such a way that we can then continue on and finish off our program and complete it, which is absolutely awesome. So that's kind of what errors are made of. Why don't we take a look at one more error? Rather than this one, Bob, let's take a look at another error. Why don't we try to do something a little bit more advanced, maybe? Let's try to encode something. Let's try to encode, or decode rather, let's try to, what are we going to do? Let's try to decode a Unicode character incorrectly. So this is going to be a Unicode. That's a Unicode character, and we're going to decode it. Only it's not going to work because we're missing an O from the start of our character, a 0, I mean. So we're going to have that in. We're going to try and decode that from UTF-8. Yeah, that's what we're going to try and do. And let's see what kind of error it gives us back. Off we go. And it tells us here that we've got a Unicode decode error. So how do we handle this? Well, we don't even really need to know anything about the error at this point. We just need to know the pattern of handling it, which is try, except the name of the error, which we've got right here. So it's a Unicode decode error, which I'll just dump there for now. So we're going to try and do this. And we're going to accept a Unicode decode error. There we go. Let's accept that as E. And then why don't we just go and help E and see what we can find out about this Unicode decode error. So there it is. Unicode decode error, which inherits from Unicode error, value error exception, base exception object. And let's see if we can find anything useful to work this out. Oh, there we go. So we've got E, and so now we can try some of these. So we can try, just grab that and paste that here a few times. There we go. So now let's try printing e.encoding, e.end, e.object, e.reason, and e.start, and let's see what that comes up with. So all we're doing is we're just using the documentation to see if we get any useful information for ourselves about this error. So we can tell that we're trying to encode it in UTF-8. And this is all information from within the exception object. The start is, the end is position 1. That's the object that we're trying to decode. Invalid start byte. That's useful. Invalid start byte. So there's a problem with this string right here. And then fin. So as it happens, I know what the problem of this is. So there we go. So that was the problem, and we've now resolved that. So now we're no longer having that exception because we've resolved it. But you can see that we've got all of that useful information. Now one more thing about what exactly an exception is. We've we've kind of said here that, you know, this exception here, the module not found error, inherits from import error, exception, base exception. Well, that basically means that if I wanted to, I could substitute module not found error for import error, because everything that's in module not found error is kind of in import error, and this still works. So you see that still does the same job as before. Right, so we've covered how to handle errors. We've covered what errors are made of and how to kind of look into errors. Now, what happens if you get an error while handling an error? And so let me show you what I mean. So why don't we go ahead and there we go. Why don't we go ahead and print E here? But let's say that this happens. Let's say that while handling this error here, let's get rid of this help as well, because that's generating a lot of lines we don't need. Whilst handling this error here, let's say that we do another stupid thing, and let's go with 0 divided by 0, because we already know how that looks. I'm going to move this up to the top here because that's what we're doing now. So if we try to handle an error and do something stupid in the process of it, then of course we get this 0 division error here. But it also tells us during the handling of the above exception, another exception occurred. So basically, it tells us where this error happened, as well as telling us that it was an error. And so whilst dealing with this problem, another problem happened. So let's try this. Let's try 0 divided by 0. Let's accept 0 division error as, let's accept that as F. And what we should be able to do now is we should be able to print, let's just for now print F and see what it says. So there you go. So there's been a 0 division error whilst this error has happened. We've also had a 0 division error, but now we can also get some additional information about these errors too. So why don't we print, let's have F dot and then underscore context, and let's see what we get there. And it tells us that the context of this error F was UTF-8 codec cannot decode, which is the same as this. So effectively, dot context is telling us that this error, it tells us where this error happened. So this error happened while this error was being dealt with. And we can just prove this is E. So we can say f.context is E. So if this is basically telling us where this happened, which is whilst this error was being dealt with, then this should be the same as that. This should be the same as this error. So let's see if that's the case. Off we go. And we can see here that that's true. We can see here that it's true that f.context gives us access to basically the place where this error occurred, where F occurred. And the place where this error occurred was whilst this error was being handled. So that's useful as well. How about we take a look at one more thing? Because actually, if all of these errors are inheriting from one another, so let's just go back to E again, and let's just go help and E, and let's just take another look at that. We can see here that if all of these errors are kind of inheriting from one another, then surely it must be possible for us to also make some kind of a class which inherits from one of these exceptions and then to use it. So how about we now put this to the top as well? So let's look at explicitly chaining errors and making our own errors. So what I'm going to do is I'm going to create my own class. I'm going to call it Meltdown. And what I'm going to do is inherit from base exception. So I'm inheriting from base exception. And basically now I'm just going to say pass. So I've got an empty class, but I do have the namespace Meltdown, which inherits from base exception. So let's do this and let's see what happens. We're going to create ourselves a function where we're going to make an error happen. And let's call this bad news. So we've got this function called bad news, and inside bad news, we are simply going to raise an exception Meltdown. and we're just going to have some text in here that says things are not good. All right, so things are not good. And let's now delete the rest of this. Let's call our function and let's see what happens. So bad news, and off we go. And we can see here that we've raised meltdown, things are not good, and we've got some traceback. And it even says here, meltdown, things are not good. So it's raised our error for us. So we've created our own error and we've been able to raise it in this function. Now, what's the significance of this? Well, because we've created our own error, if you like, inheriting from base exception. And by the way, this is no different to any other error. All errors inherit from base exception. What we can do is we can say try bad news except, and then we're just going to print, why don't we just print whoops? There we go. Let's just print whoops. Off we go. There we go. Whoops. So we haven't got the same error messages before. Try, except, whoops. But again, we don't have much information. So why don't we accept explicitly meltdown as E and print that. And you can see now that we get things are not good. So we're getting the information that we programmed our error to give us. Now, let's look at one more thing that we can do with this. So why don't we now try again our 0 division error. Let's try to divide by 0 again, because computers love that sort of thing. Except 0 division error as E. There we go. And when we see this error, what we're going to do is we're going to raise except meltdown as E. Now we can run this, which isn't a problem. Let's run it. There we go. Things are not good. But why don't we do this now? Why don't we go E context, and let's see what that tells us. And that tells us that this happened, that this meltdown error happened within the context of trying to do a 0 division error. Let's have a look at another thing. Why don't we have a look at the cause of this error? E.cause. Here we go. It tells us that the cause is none. That really was not what I was after at all. That absolutely 100% was not what I was after from that cause. So what I was hoping for there was it to give me some information, because this is an explicitly chained error. I thought this was an explicitly chained error, but it's in fact giving me none. So let me have a little think about why that is. Right, anyway, so we know that the context thing's working. I think that, except, I think actually what we've got to do here is we've got to accept this error from E. There we go. So if we explicitly say that we want to raise this error as a result of this one, then I think there'll be something in cause. There we go. Okay. So basically context and cause both tell us the same thing, but cause will only work if we've explicitly raised an error from E. If we've explicitly raised this error using the object, which is this error's object. So what have we just done? We've had a look at how to handle errors. We've had a look at what errors are made of. We've had a look at how to deal with errors whilst handling other errors. And we've had a quick look at explicitly chaining errors. And to be honest with you, there is not an awful lot more to say about errors. So that's pretty much